I'll just quickly recap what we just discussed. So we just discussed that a pointer is a variable which stores the address of another variable. A pointer can also be called as a pointer variable, a pointer, or a single pointer. A pointer can store only the address of variable whose data type is same as that of a pointer. Meaning you can store an integer variable's address in integer pointer and a float variable address in float pointer. You cannot store an integer variable's address in a float pointer. Remember that. Next one is syntax. The way we write syntax of variable pointer variable is same as that of a variable. So we write data type and the pointer name. But the only difference is we put a star before it. Star is also called as a dereferencing operator. Okay, so this is about basic top of pointer. Okay. Now what we just did here in this code is we wrote a variable a. Okay, a contains a value 5, initialized with 5, and there is an integer pointer declared here, ptr. That ptr stores the address of a. Okay, and then we are printing variable a as well as the address of a. So we got some output like this: a is 5 and ampersand a is equal to some number. This number is the address of a. And then immediately what I am doing is I am printing something. I'll say ptr is equals to %id, comma ptr. Can you guess what will be the output for the third print statement? What ptr holds? Mana something's 5, others address of a, address of a. Very good, Shalu and Mansa. See, in the ptr, what are we storing? Address of a. So what will come? Address of a. That means ampersand a and ptr both should be same. Now check here. Did we get the same numbers? Of course, there will be some negative numbers. Ignore that, but just check. Are the numbers same? Yes. That means in the ptr we kept the address of a properly. Then what I will do is I'll try to print backslash and let's print address of ptr. What is address of ptr? Address where ptr is stored. Can you guess what number that might be? Address of ptr power. Just like variable a, ptr is also stored. Also has some address. Puneet, it's not hexadecimal value, it's normal value, but representation will be in here, it is in integer. The answer will be in integer. Address of ptr is also some random number. Okay, but you have to observe this. Let me get a positive number for ptr now. You can observe a address is 172. That means it stores, it requires 4 bytes. So it is stored in 172, 173, 174, 175. 4 bytes of memory is occupied. Now this we have seen in the last class, 1D array class. I was explaining when continuous allocation happens, 4 bytes are taken, the next value will be 176. But here if you observe, the 176 is taken by the PTR. Am I clear here? Why 176 is coming here? The difference is 4 bytes, it is being occupied by variable A. Everyone. Is this point clear? Very good. Now let us print. Let us print star PTR. What is star PTR? What is star PTR? Value at PTR, value of A, that is 5. Now observe here, what are we getting? Star PTR is equals to 5. Is this clear so far? If you don't want that to be coming, just put LD here. When you keep LD, you won't get negative numbers. Understood this? Should I explain once again? Now, pay very clear attention here. We have a variable. Let's say black looks better. We have a variable A, okay, which has 100 address. Then we have star PTR, okay, which has address 104. Now, why do you think there is 104? PTR is holding the address of A, by the way. Ritu, tell me why the address of PTR is 104. Why not 101? If data type is integer, what is happening there? Good, Manasa. The data type is integer. Integer require 4 bytes. So 4 bytes are allocated for A. What is 100, 101, 102, 103. So the next address is 104, which is empty, being occupied by the point of PTR. So that is what also happened in the code here. Again, observe. The address of A is 444 and the PTR address is 448. 4 bytes is taken by variable A. Okay, that is what I was telling earlier. Now, you remember one important thing. That important thing is whenever you see an ampersand, read it as address of. And whenever you see a star, read it as value at. Remember this. Whenever you see an ampersand, read it as address of. And whenever you see star, read it as value at. Am I clear? Everyone, am I clear? Now give me what is A value? Five. Very good, Pavan. Try to respond, everyone. This is where you try to learn completely. Pointers concepts. Pointer is a little bit confusing, but if you learn it properly, it will be very easy. Good, Ritu. Good, Datta. Others. Very good. What about address of A? What's the value here? Looking at the map, memory mapping there, tell me. 100. Very good. Read as address of A. Address of A is 100. What about PTR? Very good. PTR is what's present inside the variable PTR. That is 100. So print 100. Now, what is ampersand PTR? Address of PTR, that's 104. Very good, guys. What about star PTR? Now read it as value at PTR. You might have a doubt why star PTR gives you that 5. Observe carefully. We know that star is there, then PTR means 100. So star read it as value at. So value at 100 is 5. Are we clear here? Everyone. So this is a single pointer. So keep that in mind. Next. Now we will try to write, okay, another one. That is double pointer. What's a double pointer? What's a double pointer, by the way? Value at first variable, no. No idea. That's a double pointer stores address of a single pointer. Okay, so it's to if variable's address is stored, it's called as pointer. If pointer's address is stored or single pointer's address is called, it is double pointer. Am I clear here? We store address of single pointer, it's called double pointer. Now, what about triple pointer? What triple pointer does? Exactly, Navindu. Others, what double pointer does? Triple pointer does? Stores address of triple pointer. I'm sorry, double pointer. That's it. Single pointer address is stored in double pointer. Double pointer address is stored in triple pointer. Okay. So what is syntax of the double pointer then? It is also same data type, pointer name, semicolon. But here there will be two stars. So two star is present. That means it is a double pointer. Are we clear? Sure. Let's write a little code for it as well. Or let's write this mapping, then we'll go for code. Okay. Now listen. Let's say I am making just a minute. Again, this pen is malfunctioning. Yes. Let's make a QTR. QTR is a double pointer. And what will I store in the double pointer? What will I store in the double pointer? What is store the double pointer? We just discussed. Get me the value. What will I store in the QTR? Go to Ritu, address of single pointer. Go to Himanshu. Good Georgia, Kumar, good power. So what's the value I will store inside QTR? The address of PTR, that is 104. Okay. Now observe here carefully. Now address of A is 100, address of PTR is 104, address of QTR is 112. Why is the difference? Can someone tell? Raja Kumar, if you observe A and PTR, difference is 4 bytes. That means A is occupying 4 bytes. What about PTR and QTR? Not 117. Understand here. 112 minus 104, that is 8 bytes. So depending on you are using a 32-bit system or a 64-bit system, the address of pointer varies. So when you should understand like this, if your integer variable size is 4 bytes, then your pointer variable size will be 8 bytes. Understood this? And if your integer variable size is showing as 2 bytes, your pointer variable address will be showed as 4 bytes, depending on the system configuration changes. Okay. Now tell me this. I have QTR. What's QTR value? Very good. 104 it is. What about address of QTR? Quick answers, guys. 112, 112, very good. 112. I think I'm receiving the message a little late. Nice. What is star QTR? we're getting 5, 104, 100. You can understand like this. Keep star as this. What's QTR? 104. So how do you read star as? Read star as value at. Value at 104 is 100. So star QTR is 100. Similarly, how about star QTR? Fine, very good. So star 104. This is basically star 100. This is basically value of 100 is 5. So answer is 5. This is clear, everyone? Chalo. I hope the pointer concept is not difficult for you now. Let's write a few things. Let's write QTR is equal to percentile LT, comma QTR. So this is ampersand QTR, this is star QTR, this is star QTR. We have the same thing here. Star QTR. Here it is star QTR, here it is ampersand. Now observe same thing we will get. Even is something that you forgot to create QTR, my bad. Let's create integer star QTR. In the QTR, keep the address of PTR. Now run the again. Observe the output very carefully. Now you see, A value is 5. Address of A is ending with 708. Now we store that in PTR. So PTR is 708. Address of PTR is 712. Okay. Now how much is the difference here? 4 bytes, meaning A is occupying 4 bytes. Then star PTR value of A is 5. Then QTR. Okay, that is address of PTR 712. Now it's the same thing, observe here. And then address of QTR is 720. Now observe the difference here. How much is the difference? 8 bytes. That means size of integer, integer variable is, sorry, pointer variable is 8 bytes. And then star QTR meaning address of A, you got it 708. And star QTR value of A, that is 5. Understood? Now this is basically you gave a duplicate key to your roommate, and your roommate gave another duplicate key to his friend. So single pointer, double pointer. We can also make a triple pointer. Am I clear so far here? And is the pointer concept clear completely? We need some responses here. Fantastic. Let me just save this code. I think we can save it. Let's open a new notepad for us. Still, I can't stop. It's fine. Just take a screenshot of this so that it will be easy for you. Done. If you're done, you drop done. I'll go with the next thing. Sure. Now let's make it a little complex. Okay. What I will do is, let's say I have a variable. I think I should have something. Let me just check if we have a PPT that should be little helpful for us understanding pointers more. Let's go with FDC. Pointers. So here if you observe, pointer was 2 bytes, memory was 2 bytes and all. You can now tell me this. What is a value? Very good. What is ampersand a? What's ampersand a? Address of a. What is the value? You can see here, Rajkumar. 1,000. Good, Bindu. Sridatta, Ritu, nice. What's P? What's P? Also 1,000. Very good. Address of P? Very good. 2,000. What is star P? Value at 1,000. That is 10. Good, Raja Kumar. Good, Ritu. What about C? Address of P, that is 2,000. Very good. What is ampersand C? Very good. What is star C? Value at C. Good, very good, guys. 1,000 it is. What is star C? Very good. 10. Good. Charita, new name. Good. Gautam, new name. Very good. What is D? Very good. 3,000. What is ampersand D? 4,000. Very good. Star D. Value at D. Star D means value at D. Very good. 2,000. What is star D? Good. I can see new names coming up. That's pretty good. Shanwas is back today. Good. Devyani. You can do like this as well. Let's say you are at D. Okay. So when you are at D, what you can do is you just observe the number of stars. Number of stars are there, that many jumps you make. So you already there is one star. So one jump, you go to 2,000. There are two stars. So make two jumps. So you will come to 1,000. And then there is three stars. So what would I do? Three jumps. So 3,000 to 2,000 to 1,000 to 10. So the answer is 10. Is this clear? Shall we have a little more practice on this to make our concept solid? Okay. Now look at here. Again, there are a few, but make sure you do it properly this time. And I want everyone to answer it here. మీకు ఇక్కడ చాలా బాగా వస్తేనే నా నెక్స్ట్ కాన్సెప్ట్ మీకు అర్థమైంది. సో ఇది జాగ్రత్తగా వినండి. వాట్ ఈస్ ఏ? Very good. 10. What's P? What is P, guys? Very good. Ampersand P. Very good. Star P. Value at P. What's value at P? P ఏముంది 1000, వాల్యూ అట్ 1000 ఎంత? మళ్ళీ 1000 ఎందుకు ఇస్తారు? 10 it is. నాకు స్లో మెసేజ్ వస్తున్నాయి. ఓకే. 10 it is good. Savita, Sandhya, Vaishnavi, Manshu, Pushmita, good. Ritu, Shanwas, Raghukumar, Sandhya, good. What is PP? Oh, PP again. What's PP? 3,000. Very nice. What is ampersand PP? Address of PP. That's 5,000. Very good. What is star PP? Value at PP. Value at 1,000. So 3,000. That is 1,000. Mohanty, value at 3,000 is 1,000. What is star PP? Very good. 10. What is B? 20. Very good. What is Q? 2,000. Very good. What is star Q? Star Q. Value at 2,000. That is 20. What is star star Q Q? $20. Very good. So I hope most of you have got a clear picture of pointer and how address of pointer are stored. But what happens? We make a small change here. Okay. Now we made P is equals to Q. Now give me what is A value. Look at carefully and give. Very good. P is 1000 by the way here. A is 10. What is P? P is 2000. 2000. What is ampersand P? 3000. Very good. What is star P? Last time it was 20, but it's a 10, but this time it is 10 because the address has changed. P is now storing Q, same as that of Q. Address of B is stored. Okay. What is PP? What's PP? 3000. Very good. What's star PP? Star PP. 2000. What is star star PP? $20. Very good. What is B? Also 20. Q? 2000. Star Q? Star Q 20. Star star Q Q. Good, quick responses, guys. Right. I hope this is pretty clear to you. I think sufficient for today's practice. What's the answer for this, by the way? What's the answer for this, guys? These are things 10, 20, others. C, D, nice. Observe. So we have initially I as well as J. I stored 10, J stored 20. Assume 100, 200. Then we have star P storing 10. That means this is basically P is equal to address of Y. In another way, we'll write star P equal to Y. So what happens here? Let's say in 300, 100 is stored. And then Q equal to ampersand J. So in the Q, we are storing 200. Assume this is 400. They're asking star P and star Q, that is 10 comma 20. Understood this? It's not the error, it's fine. Correct only. Understood everyone? Chalo. Start changing out. Close this out. When you write star p equal to I, yes, directly it is stored. Address is directly stored. So you need not to specify there. Okay. So let's understand the next concept. What's the next concept? Types of pointers. How many types of pointers do we have? Double triple is not types basically. That is one other classification. I'm talking about here types of pointers. Anyone, any idea? Anyone, any idea on types of pointers? Null pointer, good. Shravani, and others, any other pointer you know? Null, void, very good. Function pointer, no. Double pointer is not this classification. Sure. Let me explain. There are 8 types of pointers. Okay. Let's start from first one. The first one is null pointer. Second one is wild pointer. Third one is dangling pointer. Fourth one is null while dangling void pointer. Fifth one is near pointer. Sixth one is huge pointer. Seventh one is near or huge. Let's put this as fire pointer. Then comes huge pointer, and then comes complex pointer. So these are the types of pointers. 8 types of pointers. Out of this 4, the last 4 we won't use at all. And why don't we use it all means they are no more used. Near pointer is of 16-bit address register memory, 8-bit register memory. Far is 16, huge is also 16, but size difference and all. So these were used uh, years before. Now this doesn't have much use. Even if you try to use this, they will throw you an error. C9 standards, it will throw you an error. Okay, you can't use this. Coming to complex pointer, complex pointer is for complex variable. Again, this we don't use in C9 standard. But some part of ANSI compilers use these things still, but now now the modern compilers can't use this 4. It only uses the above 4. Null, while, dangling, and void pointer. By the way, void pointer is also called as generic pointer. Okay, so let's learn this null pointer. Okay, what is null pointer? Any idea? Points to null, no value. There is a value null, Pawan. So we declare a pointer int star ptr. Okay, in the ptr you assign null. Then it is called as null pointer. Even if you print in terms of percentile d, and I print ptr, now observe the answer we are going to get is 0. Why 0? Because null in decimal is 0. So it points to null. If we don't put null, then what happens? I'll show you. Assume this is not there. Okay. And just the PTR is there. I'll give a run. Now observe what is the output. Okay, this is showing null, 0, but actually this contains some garbage. Okay. Nowadays all computers are giving 0, so garbage. Okay. So garbage is stored. Garbage is what basically a number. What if that number is an allocated address? Then that is a problem. So that is why we keep null. Null specifies that right now my pointer is not pointing anywhere. Basically nothing, null. Clear? Are we clear with null pointer? Very good. Let's go with next one. What's the next one? Wild pointer. Let's understand wild pointer. What is wild pointer? Here it is called as wild pointer. Do you know what is a wild horses? What's a wild horse? Or wild animals? What are wild animals? Yes, what are wild animals, guys? ఇది కూడా కష్టమేనా? Give responses. Lives in forest, basically untamed. Untamed అంటే పెట్ చేసుకోలే మనం దాన్ని ఇంకా. సో మనం చెప్పిన మాట ఏంటో వినదు. Random గా ఎక్కడెక్కడ తిరుగుతూ ఉంటుంది. ఓకే, సో దట్ ఈస్ untamed. సో దట్ ఈస్ బేసికలీ వైల్డ్ పాయింట్. ప్రజెంట్ ఈ పాయింటర్ ఎవరిని పాయింట్ చేయట్లేదు, డిక్లేర్ అయింది, బట్ నాట్ పాయింటింగ్ ఎనీవేర్. దెన్ దేర్ ఇస్ అ వైల్డ్ పాయింటర్. దట్స్ ఇట్, ఏం లేదు అంతే. A pointer is declared but not initialized, then it's called wild pointer. Understood? So a pointer is declared but it is not initialized. ఒకసారి ఇనిషియలైజ్ చేసిన తర్వాత it is no more a wild pointer. మీరు ఒక హార్స్ తెచ్చుకొని దాన్ని ట్రైన్ చేసిన తర్వాత మళ్ళీ అడవిలో వదిలేస్తే it is no more a wild animal. Okay, remember that. Same thing here. What about a null pointer? A pointer which stores null value is called as null point. అర్థమైందా? ఇది null point. ఇది wild point. So what next? A dangling point. What is this? Dangling point. Let's see how a dangling pointer works. Now observe here how I will write. Let's take a variable a is equals to 5. Then I will make between which both power? I've explained. In null pointer, we keep null. If pointer contains null, it is null pointer. But if you observe this, when I declare the pointer in fourth line, I did not assign anything. Then it is wild pointer. The moment I assigned null, it became null pointer. Let's see the next one. Let's say I'm making a pointer PTR. Okay. We're discussing dangling pointer, no? Yeah. Okay. ఇప్పుడు ఇది ఏంటిది? ఇక్కడ ఏం రాలేదు మనం. So this is wild pointer. In the PTR, now I assign address of A. Now this is a normal pointer. Okay. Now observe very carefully. I'll just print %d, comma star, PTR. What will be the output? Obviously, I'm going to get 8. And then what will I do? I'll write this line once again, but in between, I'll just write a free function, free the PTR. Now, for that, I have to use hash include stdlib.h. Do you remember free function? What's the free function? Anyone? Good, it deallocates the memory. Very good. So I'm deallocating the value assigned to the PTR. Now observe. ఏమైంది ఇక్కడ ఏమొచ్చింది? ఇన్వాలిడ్ పాయింటర్ వచ్చింది. ఎందుకు ఇన్వాలిడ్? నేను రిమూవ్ చేసిన కదా. రిమూవ్ చేసినాక పని చేస్తా మళ్ళా? పని చేయదు. ఎందుకు ఏమొస్తుంది? ఇది ఇన్వాలిడ్ వస్తుంది. The moment I remove this, make it a comment and I run this, ఇప్పుడు బాగా వస్తుంది. 5 it's working fine. The moment I use free, పాయింటర్ ఫ్రీ అయింది. పాయింటర్ ఫ్రీ అయిన తర్వాత if I try to print star PTR, అప్పుడు ఏమొస్తుంది? ఇన్వాలిడ్ పాయింటర్. అదే పాయింట్ చేయట్లేదు కదా అంటుంది. అర్థమవుతుందా? Are we clear? Everyone? So this is a దీన్ని ఏమంటాం? డాంగ్లింగ్ పాయింటర్ అంటాం. ఇంతకుముందు మామూలు పాయింటర్ లో పనిచేసింది. మనం ఇనిషియలైజ్ చేసిన వర్క్ అయింది. The moment you free, it is free and it is no more pointing anywhere. Then it is called as dangling pointer. అర్థమైందా డాంగ్లింగ్ పాయింటర్ అంటే? Are we clear, everyone? Let's copy this, write this here. What's a dangling pointer? A pointer which no more points to any location. A pointer which used to point to a location, but now, but now it no more points to any location. So this is called as a dangling pointer. అర్థమైందా? Everyone, am I clear? Now let us understand what is a void pointer. Okay, a void pointer is a pointer which can be used by any data type. The first line we learned after learning pointers, a pointer can only store address of its same data type. కదా int pointer చేస్తుంది int address store చేస్తుంది float pointer float address. Can int pointer store float address? Of course not. Are we clear with this point?
Yes. Yes.
Yeah, what I'm telling is an int pointer can store integer address. A float pointer can store float address. Can an int pointer store float variables address? Good, Ritu. We cannot store address of a float variable in an integer pointer. I'll show you. Look at here. I make integer variable a is equals to 5. I'll make star integer pointer star ptr equal to address of a, and I am gonna give print statement percentile d. Okay, and I will write star ptr. I'll give a run. Answer ఏమొస్తుంది? You missing anything? Comma is missing. Let's put a comma. We see we got 5. Are we clear with this? Now I'll make a float variable. My pointer is float pointer type. I'll print this. Now what is coming out? Garbage. Why? It's basically an error. And what's the error? Float star from incompatible pointer type int star. Int star ఉండాలి నీకు. అది float star అది incompatible pointer అని చెప్తుంది. Are we clear here? Chalo. Now what I'll do is I'll just make it as void pointer. Now observe, when I make void pointer, I have to convert this pointer to integer star. Now observe, this will work fine. Now in the same PTR, I will store address of float variable f, where my float f is equals to 12.5. Now I'll give a print statement. I'll give percentile d, percentile f, sorry. Give a next line, it will be easier. Next line, percentile f, comma, star converted to float PTR. Now tell me, is my PTR integer pointer or a float pointer? Because if I run this, I'm getting both the answers. Oh, where I missed it. Float pointer, yeah, one star I missed. I explained that conversion. Now observe here, I got two answers, 5 and 12.5. Now, is my PTR an integer pointer variable or a float pointer variable? Tell me, guys. బాబు రెండు కాదు, అది వాయిడ్ పాయింటర్. మీకు కాన్సెప్ట్ అర్థమైందా? ఇది మళ్ళీ చెప్పాలి ఒకసారి. మళ్ళీ చెప్తాను, యు లిసన్ కేర్ఫుల్లీ. ఓకే, ఫస్ట్ టైప్ కాస్టింగ్ గురించి నేర్చుకుందాం. ఓకే, సో వాట్ ఐ డూ ఇస్, లెట్స్ మేక్ percentile d comma 5. What will be the output if I print 5? Obviously I will get 5. Okay, I got 5.6. I'll still print percentile d. అప్పుడు ఏమొస్తుంది? గార్బేజ్ వస్తుంది. ఎందుకు గార్బేజ్ వస్తుంది? ఇది ఫ్లోట్ వాల్యూ, నువ్వు ఫార్మాట్ స్పెసిఫైర్ ఇంటీజర్ ఇచ్చావు. ఓకే, సో ఇట్స్ మిస్ మ్యాచింగ్. బట్ నేనేం చేసింది తెలుసా, ఈ 5.6 ని ఇంట్ కన్వర్ట్ చేశాను. దీన్ని టైప్ కాస్టింగ్ అంటాం. ఇంకో భాషలో కన్వర్షన్, టైప్ కన్వర్షన్. ఇంకో భాషలో ఎక్స్ప్లిసిట్ టైప్ కన్వర్షన్. Now I converted this 5.6 to integer and percentile d is matching for integer. Now when I run this, I'll get 5. ఇది అర్థమైందా? సిమిలర్లీ ఇప్పుడు చూడండి, నేను ఫ్లోట్ ఇచ్చా, ఫ్లోట్ ఇచ్చి ఐ గివ్ 6. అప్పుడు ఏమొస్తుంది చూడండి, ఏమొచ్చింది? అన్ని 000 వచ్చిందా? నా ఎందుకని 6 ఇంటీజర్, ఫ్లోట్ ఏమో ఎఫ్ ఏమో ఫ్లోట్. సో దీన్ని ఫ్లోట్ కన్వర్ట్ చేద్దాం. ఎఫ్ఎల్ లో 80 ఫ్లోట్ కన్వర్షన్, జస్ట్ టైప్ కాస్టింగ్. అప్పుడు ఏమైంది? వచ్చిందా 6.0? ఇది అర్థమైందా? ఆర్ వి క్లియర్ విత్ దిస్ యాజ్ వెల్? వెరీ గుడ్. సో వాట్ ఐఎమ్ డూయింగ్ ఈస్, ఇఫ్ అట్ ఆల్ నా డేటా టైప్ మిస్ మ్యాచ్ అయితే నేను ఎక్స్ప్లిసిట్ కన్వర్షన్ చేసుకొని ఐఎమ్ యూజింగ్ ఇట్. ఓకే, ఇది వాల్యూకి. అదే నేను పాయింటర్ మార్చాలంటే స్టార్ పెడతాను. అదే పాయింటర్ కన్వర్షన్, పాయింటర్ టైప్ కాస్టింగ్, డబుల్ పాయింటర్ అయితే 2 స్టార్లు పెడతాం. వేరియబుల్ అయితే ఏముండదు. పాయింట్ అయితే సింగిల్ స్టార్, డబుల్ పాయింట్ అయితే డబుల్ స్టార్, ట్రిపుల్ పాయింట్ అయితే ట్రిపుల్ స్టార్. ఆర్ వి క్లియర్ విత్ దిస్? So let's listen to this. So ఇక్కడ ఏం చేశానంటే I made an void pointer. If I make this int pointer, now you observe, I'll give a run. ఇక్కడ ఏమైందంటే regulation still printing out. వార్నింగ్ ఎర్రర్ రావాలి యాక్చువల్గా వస్తుంది బట్ చూద్దాం. ఇక్కడ ఏమైందంటే when I make int pointer, int అడ్రస్ స్టోర్ చేసుకొని ప్రింట్ చేస్తే బాగానే ఉంది. ఫ్లోట్ అడ్రస్ పెడితే my output is int pointer from incompatible pointer float pointer అంటాం. అది అనకూడదంటే ఏం చేయాలి? మేక్ ఇట్ యాజ్ వాయిడ్. సో బేసికలీ దీనికి ఏ పాయింటర్ లేదు. దిస్ ఇస్ బేసికలీ వాయిడ్ స్లాష్ generic point. ఓకే, ఇది స్పెసిఫైడ్ డేటా టైప్ కాదు. హౌ డు ఐ యూజ్ ఇట్? ఇలా ఎక్స్ప్లిసిట్ టైప్ కన్వర్షన్ చేసుకో. ఆ పీటీఆర్ ని ఇంట్ కి మార్చుకో, యూ రైట్ ఇట్. అండ్ అదే పీటీఆర్ ని ఫ్లోట్ కి మార్చేసుకో, అగైన్ యూ రైట్ ఇట్. అదే పాయింట్ ని క్యారెక్టర్ కి మార్చుకో, యూ యూజ్ ఇట్ అగైన్. సో a void pointer can be used by any data type at a particular instance by changing or typecasting it. Are we clear? చాలా ఇంపార్టెంట్. నెక్స్ట్ సెకండ్ హాఫ్ సెషన్ కి ఇది చాలా ఇంపార్టెంట్ కాన్సెప్ట్. Everyone clear with this? So this is void pointer. What's a void pointer? A pointer declared void is called as void pointer. It can be converted to required data type, and then it can be used. Am I clear? Everyone, with all the pointer concepts? Any doubt anywhere? Guys, any doubt anywhere? Very good. Pointer concept clear అయింది కదా? I've shared that PDF text file as well. Let's check that once. Sure, అయిపోయింది. Now we have 10 more minutes. So you ask any doubts regarding pointers or any concept prior to that before we take a break. Anything you want me to tell once again? Okay, I shared, but I don't know when first either. Let me share once again. Sure, Himanshu. Look at here once. Generic అంటే ఏంటి? Can be used generally. ఎవరైనా యూజ్ చేయొచ్చు. ఓకే, సో ఇక్కడ ఏమైందంటే I'm gonna take one more this file to explain it. Let's take దీన్ని నేను int pointer అనుకుంటున్నాను. int pointer అనుకొని I'm printing. ఓకే, int pointer లో ఏం చేశాను, ఫర్ నౌ ఫ్లోట్ లేదనుకుందాం, ఇది కామెంట్ చేద్దాం. I take a integer variable, I take a integer pointer, అందులో అడ్రస్ ఆఫ్ ఏ పెట్టాను, పాయింటర్ ప్రింట్ చేసాను. అప్పుడు ఏం వస్తుంది నాకు అవుట్పుట్, మై అవుట్పుట్ విల్ బి 5. బాగానే. నెక్స్ట్ ఏం చేసిన అంటే ఇంకొక ఫ్లోట్ వేరియబుల్ తీసుకొచ్చి ఫ్లోట్ వేరియబుల్ 12.5 పెట్టి దాని అడ్రస్ ని మళ్ళీ పీటీఆర్ లో పెట్టాను. మై పీటీఆర్ ఇస్ ఇంటీజర్ పాయింటర్, మై ఎఫ్ ఇస్ ఫ్లోట్ వేరియబుల్. నౌ దేర్ ఇస్ డేటా టైప్ మిస్ మ్యాచ్. ఐ ట్రై టు రన్ దిస్ అవుట్. అప్పుడు ఏమొచ్చింది చూడండి, ఇలా 000 వచ్చింది. అండ్ ఏం చెప్తుంది, యాక్చువల్లీ ఎర్రర్ రావాలి. ఏం చెప్తుంది, నీ ఇంటి పాయింటర్ ఏదైతే ఉందో ptr is int pointer from incompatible pointer type float pointer. నీకు కావాల్సింది ఫ్లోట్, కానీ అక్కడ ఏముంది, ఇంట్ ఉంది అంటారు. అర్థమైందా? సో దిస్ ఇస్ ద ప్రాబ్లమ్ యూ ఫేస్ వెన్ యూ వాంట్ టు యూస్ ద సేమ్ పాయింటర్ ఫర్ ఎ డిఫరెంట్ డేటా టైప్. ఇది ఒక డిసడ్వాంటేజ్. దీన్ని ఎలా మార్చుకున్నాం మనం, we made this pointer, we declared this as a void pointer. వాయిడ్ చేస్తే ఏమైంది, ఇట్ కెన్ బి యూస్డ్ బై ఎనీవన్. బట్ యూజ్ చేసే ముందు ఏం చేయాలంటే, చూడండి, ఇఫ్ ఐ రన్ దిస్ అవుట్ మీకేం మళ్ళీ కరెక్ట్ ఆన్సర్ రాదు. ఓకే, నేను మళ్ళీ ఇరవై వచ్చింది. ఇక్కడ ఏం చేస్తానంటే ఈ పాయింటర్ ని ఇంట్ పాయింటర్ కన్వర్ట్ చేసా, అప్పుడు నేను యూజ్ చేసుకుంటున్నాను. ఇక్కడ సేమ్ ఇక్కడ కూడా అంతే, కన్వర్ట్ దిస్ టు ఫ్లోట్ స్టార్, దెన్ యూజ్ ఇట్. బికాస్ సైజ్ డిఫరెన్స్ ఉంటుంది, డేటా టైప్ డిఫరెన్స్ ఉంటుంది, అవన్నీ ఉంటాయి. సో జస్ట్ మీరు కన్వర్ట్ చేసి వాడేసుకోండి. కన్వర్ట్ చేశాను, వాడుకోండి. వచ్చిందా ఆన్సర్? So when I declare void, one single pointer can be used for all different types of data types and all different type of variables. Is it clear, Himanshu, now? ఇక్కడ void అంటున్నారా, 7th లైనా? Just a minute, let me share that file once again. మళ్ళీ అది సింగిల్ పర్సన్కి వెళ్ళిపోతుంది ఒకసారి. ఇప్పుడు వచ్చిందా చెక్ జీ పవన్? 5th లైన్. హిమాంశు అదే చెప్తున్నాను నేను. ఇది వాయిడ్ పెట్టుకుంటే రకరకాలుగా యూజ్ చేస్తాం. మీకు ఇలా కాదు, ఐ డైరెక్ట్లీ ఎక్స్ప్లెయిన్ యు ద ఎంఎల్ఆక్. ఎంఎల్ఆక్ సింటాక్స్ తెలుసా మీకు? వాట్ ఇస్ ఎంఎల్ఆక్ బై ద వే? మెమరీ అలొకేషన్ కదా, నెక్స్ట్ చెప్పాలి అది. అందులో ఏమని ఉంటుంది, ఇక్కడ ఉంటుంది చూసారా, ఇంట్ స్టార్ అని. ఎందుకు ఇంట్ స్టార్ ఉంటుంది, ఎంఎల్ఆక్ గివ్స్ యూ ర్యాండమ్ లొకేషన్. ఓకే, ఆ లొకేషన్ కి ఏ స్పెసిఫిక్ డేటా టైప్ అటాచ్ అయ్యి ఉండదు. ఓకే, దాన్ని నీకు నచ్చినట్టు మార్చుకోవాలంటే ఇక్కడ ఇంట్ పాయింటర్ రాయాలి. ఇక్కడ ఏం జరిగింది, టైప్ కాస్ట్ అయింది. అదే నేను ఇక్కడ చేస్తున్నాను, సేమ్ థింగ్ ఐఎమ్ డూయింగ్ ఇట్ హియర్. అండర్స్టూడ్ నౌ? అర్థం కాకపోతే ఇగ్నోర్ చేయండి, నేను ఎంఎల్ఆర్ చెప్పినప్పుడు మళ్ళీ డీటెయిల్ గా చెప్తాను. పాయింటర్ యూజ్ చేయాలంటే దానికి డేటా టైప్ కావాల్సిందే, అది లేకుండా పని చేయదు. రాంగ్ డేటా టైప్ ఇచ్చినా పని చేయదు. మీరు ఎప్పుడైతే వాయిడ్ ఇస్తారో అప్పుడు నీకు నచ్చినట్టు మార్చేసుకొని యూ కెన్ యూజ్ ఇట్. సో దాట్ ఈస్ బేసికలీ వాయిడ్ పాయింట్. ఓకే, ఎనీ డౌట్స్ ఎనీ మోర్? Any more doubts, anyone? Shall we take a break? Break. Good. So we'll have a break, and once break is done, we'll come back. Have your break. Come back after 11:50. On 11:15 actually. Thank you all. Have a break. Come back.